Imagine you're a caveman. You have 5 apples, 3 fish, and one very important problem. How do you know if your sneaky neighbor just stole one of your fish? Today, counting feels so normal that we barely think about it. But for most of human history, numbers didn't exist. No calculators, no spreadsheets, not even the number 5. So how did humans go from scratching marks on bones to launching rockets and calculating billions of dollars? This is the strange, surprising, and occasionally ridiculous history of counting. Our story begins around 20,000 years ago with one of the strangest objects in the history of mathematics, the Ishango Bone. And no, despite the name, it is not a prehistoric dog toy. The Ishango Bone was discovered near Lake Edward in Central Africa and is believed to be one of the oldest known counting tools ever found. At first glance, it looks pretty unimpressive, just a small bone covered with carved notches. But those tiny scratches may represent humanity's first attempt at recording numbers. Imagine being a Stone Age hunter. You catch 1 fish today, 2 tomorrow, and 3 the next day. Without writing, how do you keep track? Simple. Grab a bone and start scratching marks into it. Researchers noticed that the notches on the Ishango bone are arranged in organized groups rather than random scratches. Some scientists even think they show patterns involving doubling, basic arithmetic, or prime numbers. Now, before we declare that cavemen invented advanced mathematics, it's important to know that experts still debate exactly what the marks mean. But one thing is clear, somebody was counting something. Whether it was animals, days, trades, or perhaps the world's oldest grocery list, the Ishango bone shows that humans were already trying to turn the chaos of life into numbers. And that tiny idea would eventually change civilization forever. By the time we reach ancient Egypt, counting had gone from a few scratches on a bone to managing one of the most powerful civilizations on Earth. Because it turns out, building giant pyramids is a lot easier when you know how to count. The Egyptians needed numbers for almost everything: collecting taxes, measuring farmland, tracking grain supplies, and making sure thousands of workers got fed. Imagine being the official in charge of storing grain for an entire kingdom. If you accidentally count 10,000 sacks as 1,000 sacks, somebody is going to have a very bad harvest season. To solve this problem, the Egyptians developed their own number system. Instead of using digits like we do today, they used special symbols. A single stroke meant 1. A heel bone symbol meant 10. A coiled rope meant 100. Writing large numbers sometimes looked less like mathematics and more like somebody decorating a wall with hieroglyphic stickers. Unlike our modern system, their numbers didn't use place value, so writing really big numbers could become a surprisingly crowded artistic project. But despite its limitations, the Egyptian system worked remarkably well. It helped organize massive construction projects, manage trade, and run an empire for thousands of years. In other words, before the pyramids were engineering marvels, they were counting marvels. Because behind every giant stone block was somebody with a very important job, making sure the numbers added up. If the Egyptians were good at counting, the Babylonians looked at numbers and said, "We can make this way more complicated." Welcome to ancient Babylon, located in Mesopotamia, where some of the world's most influential mathematical ideas were born. Around 4,000 years ago, Babylonian scribes were recording numbers on clay tablets using wedge-shaped marks called cuneiform. But here's where things get interesting. Instead of counting in base 10 like we do today, the Babylonians used base 60. That's right. While we're comfortable counting 1, 2, 3, 4, and so on, a Babylonian might have thought, why stop at 10 when you can count all the way to 60 first? At first, base 60 sounds completely ridiculous, but surprisingly, it's brilliant. The number 60 can be divided by 2, 3, 4, 5, 6, 10, 12, 15, and 20 without leaving fractions behind. That calculations much easier for merchants, engineers, and astronomers. In fact, the Babylonians were so successful that parts of their system still survive today. Every time you look at a clock and see 60 minutes in an hour, or a circle with 360 degrees, you're using Babylonian mathematics without even realizing it. And they introduced another revolutionary idea: place value. The meaning of a symbol could change depending on where it appeared, a concept that would later become essential to modern numbers. So while the pyramids were reaching for the sky, the Babylonians were quietly inventing mathematical ideas that still control your watch, your GPS, and even your geometry homework.
If the Babylonians asked, "How can we calculate better?" the ancient Greeks asked a completely different question: why do numbers work at all? Welcome to ancient Greece, where counting started turning into mathematics. The Greeks inherited numerical ideas from earlier civilizations, but they became obsessed with understanding the rules behind them. And when I say obsessed, I mean philosopher-level obsessed. For the followers of Pythagoras, numbers weren't just useful tools. They believed numbers were the hidden language of the universe. To them, mathematics explained music, nature, astronomy, and maybe even why your neighbor's goat kept escaping. The Greeks also introduced something revolutionary: mathematical proof. Instead of saying, "Trust me, the answer is correct," they wanted logical evidence that a result had to be true. This changed mathematics forever. Then came an awkward discovery. The Pythagoreans believed every measurement could be expressed as a neat fraction. Everything seemed perfect until they encountered irrational numbers. Numbers like the square root of 2 refused to cooperate. No matter how hard they tried, it could not be written as a simple fraction. For Greek mathematicians, this was the mathematical equivalent of finding a glitch in reality. But rather than giving up, they studied these strange numbers and pushed mathematics into entirely new territory. So while Egypt counted resources and Babylon improved calculations, Greece transformed numbers into a science of logic. And every time a student is asked to show their work, they can thank the Greeks for making mathematics about reasoning, not just answers. While Greek philosophers were debating the secrets of the universe, another civilization on the other side of the world was quietly developing one of the most advanced number systems ever created. Meet the Maya. Living in Central America, the Maya were incredible astronomers, architects, and mathematicians. And unlike many ancient civilizations, they came up with some remarkably modern ideas completely on their own. Their number system was based on 20 instead of 10. Why 20? Well, if 10 fingers helped create base 10, the Maya apparently looked at their fingers and toes and thought, "We're leaving half the counting equipment unused." The Maya used just 3 simple symbols: a dot for 1, a bar for 5, and a shell-shaped symbol for 0. And that last one is a big deal. 0 may seem boring today, but it is one of the most important inventions in human history. Without 0, modern mathematics, computers, and smartphones would be nearly impossible. What's remarkable is that the Maya independently developed a symbol for 0 centuries before it became common in Europe. Their mathematical skills weren't just for fun. They used them to create incredibly accurate calendars, track planetary movements, and predict astronomical events with impressive precision. Imagine trying to predict the movement of planets without telescopes, computers, or even electricity. Meanwhile, most of us panic when our phone battery drops below 10%. The Maya proved that great mathematics doesn't require advanced technology. Sometimes all you need are good ideas, careful observation, and a civilization that takes counting very seriously. The Maya gave the world one version of 0, but in ancient India, 0 evolved from a useful symbol into something truly revolutionary. And this might be the most important chapter in the entire history of counting. Around the first millennium CE, Indian mathematicians developed the decimal place value system that we still use today. At first glance, our numbers seem simple, but think about this. The numbers 5, 50, and 500 all use the same digit. The only thing that changes is position, and that trick only works because of 0. Without 0, there is no easy way to distinguish between 5, 50, and 500. Imagine trying to write your bank balance, your phone number, or the population of a city without it. Things would get confusing very quickly. Indian mathematicians didn't just use 0 as an empty space, they treated it as an actual number that could be calculated with. This was a huge leap forward. One of the most influential mathematicians was Brahmagupta, who described mathematical rules involving 0 in the 7th century. For the first time, 0 became a legitimate citizen of the number world, instead of just an empty placeholder. The result was the Hindu decimal system, 10 symbols, place value, and 0 working together. It was elegant, efficient, and incredibly powerful. In fact, every number you have ever typed, every calculator you've ever used, and every computer you've ever touched depends on this idea. Not bad for a number that represents absolutely nothing.
Most people spend years asking, what is the meaning of life? Algebra spends years asking, what is the value of x? And surprisingly, that question changed the world. After the development of the Indian number system, the next great leap came from the scholars of the Islamic Golden Age. From cities such as Baghdad, mathematicians collected knowledge from India, Greece, Persia, and many other cultures, then improved upon it. One scholar in particular would leave a permanent mark on mathematics, Al-Khwarizmi. In the 9th century, Al-Khwarizmi wrote a groundbreaking book about solving equations. The Arabic word in its title was Algebra, which eventually gave us the word algebra. Before algebra, mathematics was mostly about specific numbers. How many sheep do you own? How much grain do you have? Algebra introduced a new idea. What if we don't know the number yet? Instead of solving only known quantities, mathematicians could solve mysteries. An unknown number could be represented by a symbol and uncovered through logical steps. In a way, algebra turned mathematics into detective work. The scholars of the Islamic world also helped spread the Indian decimal system and 0 across vast regions through trade, education, and scholarship. As these ideas traveled, calculations became faster, easier, and more powerful. So while India gave the world a number that represented nothing, the mathematicians of the Islamic Golden Age created a method for finding things we didn't know. And every time a student groans at an algebra problem, they are participating in a mathematical tradition that began over 1,000 years ago.
By the time mathematics reached Europe, numbers had already traveled thousands of miles and survived thousands of years. But Europe would add one final ingredient that made mathematics much easier to read, write, and use: symbols. Because let's be honest, writing entire sentences every time you want to solve a problem is exhausting. Imagine if instead of writing 2 plus 3 equals 5, you had to write 2 quantities added together produce a total quantity equal to 5. Your homework would be longer than a fantasy novel. During the Renaissance and the centuries that followed, European mathematicians began standardizing the symbols we use today. The plus sign, the minus sign, the equal sign, and later symbols for multiplication, division, powers, and many other operations became increasingly common. Suddenly, mathematics became compact. Instead of describing calculations with long explanations, mathematicians could write entire ideas in a few symbols. This made calculations faster, communication easier, and learning more efficient. Scientists across different countries could now share mathematical ideas using a common language. And that common language helped fuel the scientific revolution. Physics, engineering, astronomy, navigation, and eventually modern technology all benefited from this simpler notation.
So Europe didn't invent counting, zero, or algebra, but it helped give mathematics the clean, efficient shorthand that we still use today. And if you've ever finished a math problem by writing a simple equal sign instead of a paragraph, you have these symbols to thank. Sometimes the biggest breakthroughs aren't new numbers. They're better ways to write them.
After thousands of years of counting sheep, grain, taxes, planets, and mysterious values of x, humanity finally reached the digital age. And that's when numbers became a little too powerful. Today, your computer sees the world very differently than you do. You see photos, videos, music, emojis, and messages. Your computer sees numbers. Lots and lots of numbers. Take this video, for example. To you, it's a collection of images, sounds, and words. To a computer, it's just an enormous stream of zeros and ones. Even text is converted into numbers. The letter A has a numerical code. So does B. So does every letter, symbol, emoji, and character from languages all around the world. In a computer's mind, your favorite novel and a cat meme are both just different arrangements of numbers. Images work the same way. Every pixel is stored as numerical values describing color and brightness. Videos are simply thousands of numbered images displayed very quickly. And music? That's just carefully organized numerical patterns vibrating through speakers. In a strange way, we've come full circle. 20,000 years ago, humans scratched marks onto a bone to keep track of information. Today, we store entire libraries, movies, and artificial intelligence using numbers. The tools have changed, the scale has changed, but the idea is still the same. The history of counting isn't really about numbers. It's the story of humanity learning how to represent reality itself. And apparently, reality can be compressed into an absurdly large pile of numbers.